Hey, Algebra 2 peeps, what's up? Mr. Miller here. In this video, we're going to be looking at how do we solve logarithmic equations. How do we solve logarithmic equations? And I just want to give a quick shout out to Mr. Miguel Luna because he had stopped by the classroom as I was starting to make this video, and had he not have stopped by, I would not have realized that I had my screen on the whiteboard on freeze, so you guys wouldn't have been able to see this intro slide. So thanks, Miguel, for stopping by, because that helped direct my attention to the whiteboard. Okay, so what is a logarithmic equation? Before we get into that, I guess we'll look at the objectives. So by the end of this video, you will be able to solve logarithmic equations. Kind of self-explanatory, right? Because that's the title. Okay. All right, logarithmic equations. A logarithmic equation is any equation in the variable x that contains a logarithm. Now, we don't always have to use x. Use whatever letters we want, R, S, T, L, N, E, pick a vowel, doesn't matter, because the letter is just symbolic. But this is a logarithmic equation because x is part of the thing we're taking the logarithm of. And in these two examples down here, we're taking the log of 2x and the log of x. So this is another example of a logarithmic equation. So how are we going to solve these things? Well, why don't we do some examples together? And for that, let me switch to my smart notebook screen. Get this maybe down or up. This over here. Okay, I think I'm ready. All right, so let's take a look at our first example. All right, let's say that we're asked to solve log base 8 of 5x to the minus 1 equals 1/3. What we need to do first is we have to unlock where our x is. We have to unlock where our x is. Right now, this is locked because of the logarithm. We need to annihilate that logarithm. We need to flush that logarithm down the toilet. And to do that, what we're going to do is use the base. Use the base to unlock your x, where your x is. And that's going to get rid of the logarithm too. What's our base? Our base is 8. So we're going to raise each side using 8 as a base. I'm going to have 8 to the 1/3. So notice that the 1/3 now becomes our exponent. And in a similar fashion, this left side is now going to be an exponent also. All right, so what happens here? What happens here is the 8 and the log 8 go bye-bye. They're inverses of each other. It would be similar to saying -3 plus 3. -3 and plus 3 are inverses of each other. Or 5 times 1/5. 5 times a fifth is 1. 5 and a fifth are also inverses. When this goes bye-bye, the 5x minus 1 drops down. I don't need the parentheses anymore because I'm not really having anything act on 5x minus 1. Now 8 to the 1/3, you can do that on a calculator, but I also want to point out that when you raise something to the 1/3 power, it's the same thing as saying we're taking the cube root of that, and the cube root of 8 is 2. Okay, so now we're going to do what to get x by itself? We're going to add 1, right? And then divide by 5. All right, so our solution to this is 3/5. Okay, let's take a look at another example. And let me switch to another slide. Okay, it's looking good. All right, let's say that we're going to do log of 118 minus 2x equals 2. Now what's happening here? I don't see a base. We just have the word log. What's our base? Our base is 10. If you ever see the word log with no base shown, what that means is log base 10. It's called the common logarithm, and the reason why it's called the common logarithm is because we just use it for so many things. And because we use it so much, we just drop the 10 and save ourselves some writing. Now then, how are we going to unlock where our x is? We need to get rid of our log base 10 thing that's blocking our x. So to unblock it, we're going to rewrite both sides using 10. 10 to this log 118 minus 2x equals 10 to the second. So these things on the left and on the right became exponents. These go bye-bye. The 10 and the log base 10 go bye-bye. 118 minus 2x equals 100. And what are we going to do now to get x by itself? We're going to subtract 118 from both sides. Negative 2x is going to drop down. 100 minus 118 is negative 18. To get x by itself, divide both sides by negative 2, and our x is 9. Okay? And just to top it off, let's do one more example. Why not, right? What's one more example going to hurt? Let's take a look at log base 2x. Oh, what am I saying? You idiot. Log base 10 2x. My bad. Plus log base 10 regular x equals 7. Oh my goodness, what's happening here? There's two logarithms. Log 2x and log x. You know, guys, don't let that bother you, because what we're going to do is we're going to make use of our properties of logarithms. There's one property of logarithms that we talked about was log base b of xy is the log of the first thing plus the log of the second thing. But we're going to go from right to left. In other words, we're going to condense the left-hand side. Plus product. That means I'm going to write a single logarithm, and I need to multiply the two things that we were taking the log of. Equals 7. All right, what is 2x times x? X to the first, x to the first. X to the first times x to the first, we add the exponents. So this would be inside our parentheses 2x squared, which actually the parentheses we really don't even need. I'm going to leave them off. If you like them there, it's okay. You can keep writing them. Equals 7. All right, now what do we got to do? We got to unlock the base, don't we? We got to get rid of our log base 10 is what I'm trying to say. We need to get rid of log base 10. And how do we get rid of log base 10? We use the base. This is base 10. And we're going to go 10 of log 2x squared equals 10 to the 7th. And when we use 10, the log and the 10 undo each other. They go bye-bye. That's going to leave us 2x squared equals 10 to the 7th. And on your calculator, if you do 10 to the 7th, it might be friendly and give you a nice looking number. But some calculators, depending on the number of digits they will show you, it might express it in scientific notation. So let me try to do this here on my calculator. So when I divide both sides, when I do 10 to the 7th, Then divide by 2. I get 500,000. No, 5 million. 5 million. Okay. Okay, I'm just all over the place today. God, I feel awful. This is, this is not good. Let me rewrite this. Sorry. Try to do a better job. You know, I'm not trying to make it, but something that's going on in the hallway. Sorry about that. Okay, to get rid of our 2, our square, what are we going to do? We're going to take the square root of both sides. And when I take the square root of 5 million, I get, doing it on the calculator here, square root 2,236. In Math Excel, they're going to ask us to round to the nearest whole number. So let me just show you how to do that. You go 1 digit after the dot, and 1 digit after the dot I had a 0. All right, there's more digits after the 0, but who cares about those? Because we're rounding to this place value, right? The ones place, because we want a whole number. Okay. Now, I look at 6's neighbor. If it's 5 or more, this 6 would have become a 7. If it's under 5, it stays the same. So what we would enter in Math Excel is 2,236. Okay, guys, that's it. For examples, I'm starting us off kind of basic and light in the video, and then in class we'll get some more practice with this and extend it. We'll do more complicated examples. Please remember to hop on to Math Excel and do those couple of practice problems. PCQ number 3, that's due Monday, March 12th by 11:59 p.m. Thank you guys for your efforts in class. I will see you later. Bye.